Okay, so to recap everything we have done so far. So if I'm looking at a linear relation, okay, how would the equation look like, or what kind of degree do you have for a linear relation? Degree 1. And the equation is going to look like this. Y equals mx plus b. Now, the m and the b, they're going to be letters. They're going to be numbers, sorry. So let's say 2x plus 1, okay? Or 3x plus 7, or 3x minus 5, okay? Where m and b, they're going to be numbers. And then x and y, they're going to stay x and y. But you see that the degree on the x is 1. What would be the table of value or difference table for the linear function? So when you have a table of values and when you do your first difference, or the second, I don't know if you need to do the second difference, for a linear function. What's constant for linear function? First difference. So in the table of values for a linear function, your first difference is going to be constant. And then the graph is going to be, it's a linear function. So the graph is going to be a straight line. Quadratic relation, what degree would you have? Degree 2. The equation could look like this. Y equals something x squared plus something x plus something, right? You could just have the first term and the last term, or the first term and the second term, right? So you must have the first term and any of the other terms. In a table of value, second difference is constant. And what would the graph look like? A parabola. Can it be sideways? Can it be like this? No, just up or down. This is not a parabola. If you see something like this, it is not a quadratic function. It's neither quadratic nor linear. This is actually the inverse of a quadratic. Okay, so this is not a quadratic function. Okay, so on a test, you're going to get questions like the next examples, okay, where I'm going to ask you identify, examine each question, determine the degree of relation it represents. Is it linear, quadratic, or neither? Okay, you're going to have to tell me the degree, and then you're going to have to tell me the type. Or I ask you what kind is it, and then you're going to have to say it is linear because degree 1, or quadratic because degree 2. What's the degree on the first one? Degree 1. So what kind of function is this? Linear. What degree is the second one? Degree 3. And is this linear, quadratic, or neither? Neither. The third question, degree 2, and quadratic. Yeah. The shape is parabola, yeah, but the function is quadratic. Are you guys okay with this? So if you get questions like this, you're okay to tell me this? All right. So the type is going to be, when I ask you for the type, you're going to say either linear, quadratic, or neither. And then for the reasoning for it, you can say it's degree 1 or degree 2 or degree whatever. Okay? Oops, sorry. So I'm going to give you the answers for these. So that's going to be negative 2 times negative 2, so that's negative 4 plus 1, that's negative 3. 1, 2 times negative 2. Wait, that's not right. Okay, so here are the y values. If I give you the x and the y values and I ask you to find if it's quadratic, linear, or neither, what do you do? First difference, okay? So if I do the first difference, so 5 minus 9 gives me 1 minus 5, negative 4. Negative 3 minus 1, negative 7 minus negative 3, negative 4. You guys know where I got these values from? So I just plugged in the values that are given to me in for x, and I found these values. So looking at your first difference, what can you tell me? What kind of function is it? Linear. And the reasoning for that? So you say first difference is constant. Okay, I've given you the y values and the x values. How can you determine what kind of function it is? What do you have to do? Again, the first difference first. So to do the first difference, what do I do here? Negative 1 minus 5. You start from the bottom and you subtract the top, right? So negative 1 minus 5, that's negative 6. How about the second one? Negative 3 minus negative 1. Negative 3 plus 1, so that's negative 2. Negative 1 minus negative 3, so that's negative 1 plus 3, so that's 2. And then 5 minus negative 1, which is 6. Are you guys okay with this if I don't write it out? Just because I have no room to write it out. Okay, so my first difference is not constant. Do I stop? I have to keep going. Do my second difference. Okay? So negative 2 minus negative 6 is? Negative 2 minus negative 6. Sorry, can you repeat your question? Yeah. This one? 2 times 2 squared minus 3. 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. Okay, so if I go back to my second difference, I have negative 2 minus negative 6. So that's negative 2 plus 6, which is 4. And then I have 2 minus negative 2. No, positive 4. So that's 2 plus 2 is 4. And I have 6 minus 2, which is 4. So because my second difference is constant, that means it is quadratic. Now, these are also easy right here. So by looking at the graph, what can you tell me about the first one? Quadratic. And the reason for that? Parabola, yeah. How about for the other example? Linear because it's a straight line. So these should be like easy marks for you guys, okay?